Good day, class. I'm Sir Gary and welcome to our video lesson. Before we start, let's have a recall on our previous topics. On our first lesson, we learned that the sequence is a set of numbers formed according to some pattern or rule. It is written in a specific order. And for our second lesson, we learned that arithmetic sequence should have a common difference. And if the sequence don't have common difference, therefore the sequence is not an example of arithmetic sequence. And today, our topic is arithmetic mean and end term of an arithmetic sequence. How do we able to find any term of an arithmetic sequence? For us to find any term in an arithmetic sequence, we use the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, where a sub n is the last n term, a sub 1 is the first term, n is the number of term in the sequence, and d is the common difference. Let's have an example. Determine the 10th term in the sequence of 10, 14, 18, and 22. From this example, we are asked to determine the 10th term in the sequence. And for us to find the 10th term, what we need to do is to find their common difference. And we already discussed how to get the common difference using the formula a sub 2 minus a sub 1, or by subtracting the first term to the second term. And now, using the formula given, a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Our a sub n will become a sub 10 because we are about to find the nth term in the sequence. And for our a sub 1, we have 10 because 10 is our first term. And for our n, since n is the number of terms in the sequence, we have 10. And for our common difference, we use the formula a sub 2 minus a sub 1. Our a sub 2 is 14 and our a sub 1 is 10. Therefore, 14 minus 10 will get positive 4. After getting all the values, we can now proceed to our solution. From the given, we have a sub 10 is equal to 10 plus the quantity of 10 minus 1 times 4. Using the PEMDAS rule, we need to solve first the numbers inside the parentheses. And 10 minus 1 will give us 9. And 9 multiplied by 4, we have 36. And 36 plus 10, our answer is 46. Therefore, the 10th term in the sequence is 46. Another example. In what term does 301 appear in the sequence of 4, 7, 10, and 13? In this example, we need to find n, or the number of terms where 301 will appear. First thing to do is to write all the given, like what we did on our first example. After writing all the given, we can now substitute all the values to the formula. Our formula is a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Since we don't know yet what specific number of terms do we have, given the value of 301 and a sub n is the last n term, therefore, it will become a sub n is equal to 301. And for our a sub 1, which is our first term, we have 4 and n is missing. And for our common difference, we use the formula a sub 2 minus a sub 1, which is 7 minus 4 will give us positive 3. After getting all the values that satisfies the formula given, we can now proceed to our solution. And from the formula, we have 301 is equal to 4 plus the quantity of n minus 1 times 3. From here, we can multiply 3 to the number inside the parentheses. Therefore, we have 301 is equal to 4 plus 3n minus 3. Therefore, 4 minus 3 will give us 1. And to cancel out 1, we need to subtract both sides by 1. Therefore, we have 300 is equal to 3n. From here, we are going to divide both sides by 3 and it will give us n is equal to 100. Therefore, the term having 301 is in the hundredth term. Another example. Given in an arithmetic sequence with a sub 15 is equal to 38 and common difference is negative 3, find a sub 1. For this example, we need to find what number is the first term. First thing to do is to write all the given using the formula. A sub n is equal to a sub 1 plus the quantity of n minus 1 times d. And from here, what do you think must be our a sub n? That is correct. 38 is our a sub n because 38 is the last 15th term or the last n term. And for our first term which is missing, what do you think must be n? Okay, that is correct. N is equal to 15 because in the given a sub 15 and 15 will define how many number of terms in the sequence. And for our common difference, we have negative 3. We can now proceed to our solution. And from the given, we have 38 is equal to a sub 1 plus the quantity of 15 minus 1 times negative 3. As we said, PEMDAS rule, we need to start solving the numbers inside the parentheses. And 15 minus 1 will give us 14. And 14 multiplied by negative 3 will give us negative 42. Now, add both sides by 42 or transpose negative 42 to the other side. But always remember, when we transpose a number to the other side, the sign will change. Here, negative 42 will become positive. 42 plus 38 will give us 80. Therefore, our first term is 80. Did you get it? Okay, let's proceed. For arithmetic mean, by its definition, it is the terms between any two non-consecutive terms of an arithmetic sequence. Example, find two arithmetic means of the sequence 9, a sub 2, a sub 3, and 30. From this example, we need to find the arithmetic mean between the given sequence. And for us to solve this, what we need to do is to find their common difference. But this time, we are going to find the common difference using the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Remember that always write all the given based on the formula. After writing all the given, we can now substitute the given values to our formula. And for our a sub n, we have 30, since 30 is our last term. And for our a sub 1, or our first term, is 9. And for our n, we have 4. That is correct because we have 4 terms in the sequence, which is 9, a sub 2, a sub 3, and 30. And for our common difference is missing. After getting all the values, we can now substitute all the values that we have to our formula. Therefore, we have 30 is equal to 9 plus the quantity of 4 minus 1 times d. PEMDAS rule, we need first to solve the number inside the parentheses. And 4 minus 1 gives us positive 3. And 3 multiplied by d, we have 3d. From here, we can subtract both sides by 9 or transpose positive 9 to the other side and it will become negative 9. Therefore, 30 minus 9 gives us 21. And 21 is equal to 3d. And from here, we can divide both sides by 3. And 21 divided by 3 gives us 7. And for 3d divided by 3, the 3 will cancel out, therefore the d will remain. Therefore, the common difference here is 7. We are now going to our next step. To determine the next term, we use the formula a sub n plus d. From our common difference, which is 7, our a sub n will be 9 and our common difference is 7. Just add them and we'll get 16. 16 now is our a sub 2. And from our a sub 2, just add the common difference, which is 7, give us 23. And 23 now is our a sub 3. And if we add our third term, which is 23, plus our common difference, 7, the answer will be 30. Therefore, the arithmetic means between 9 and 30 are 16 and 23. Now, let's have another example. Insert 3 arithmetic means between -15 and 1. From this example, we need to insert arithmetic means between the sequence of -15 and +1. Like what we did on our previous example, to solve this, what we need to do is to find their common difference using the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. For our a sub 1 is 1. Why 1? Correct. 1 is the last term of the sequence. And for our a sub 1 is -15. Because -15 is our first term. And for our n is 5. Because we need to insert 3 arithmetic means between -15 and 1. Therefore, we have 5 terms. For our common difference is missing. After getting all the values, therefore we have 1 is equal to -15 plus the quantity of 5 minus 1 times d. PEMDAS rule, we need to solve first the numbers inside the parentheses. Therefore, we have 5 minus 1 and gives us +4. 4 times d, we have 1 is equal to -15 plus 4d. From here, we need to add +15 both sides or transpose -15 to the other side. Therefore, -15 will become positive and 1 plus 15 is equal to 4d. Therefore, we have 16 is equal to 4d. And this time, we need to divide both sides by 4. And 16 over 4 is equal to 4d over 4. 4 will be cancelled out. Therefore, we have d is equal to 4. Therefore, the common difference here is 4. Let us proceed now to our next step. To determine the next two terms, we use the formula a sub n plus d, and using our common difference, which is +4, our a sub 1 is -15, plus the common difference is 4, we get -11, and -11 now is our a sub 2. And from our a sub 2, just add our common difference, we get -7. -7 is now our a sub 3. Add the common difference, we get -3. -3 now is our a sub 4. And when we add our a sub 4 to our common difference, we get +1. Therefore, the arithmetic means between -15 and +1 are the numbers -11, 7, and -3. And that's all for today. I hope you learned something. Thank you and God bless. Stay safe.